This is Christian Morera. I'm just going to give you a quick review of the paper Virtual Core Flow Cytometry. Now, just a bit of background. This usual standard flow cytometry is used for detecting and enumerating and quantifying different types of cells, or as well as particles, and all of this mainly aiming for immunology. So the idea is that all these cells or particles pass through a really tight beam and is pushed through by a specific type of fluid. And when the cells or particles reach where the laser light is, the system or this hardware, it will indicate, depends on the light laser, how the type of cells, and it will indicate the name or the number, or it depends on how the system is placed. So that's the basic of flow cytometer. Now there's a problem using this type of systems where it depends on the fluid in order to move those particles or cells, and it greatly increases the complexity of the system because you need to use a fluid and a mechanic thing to help that system go through, and it really creates complicated instrumentation, and it limits some sort of way the measurement that you can take. And the paper, they propose to solve it by having a system without this fluid, and it's a detector free of these requirements of the fluid, and it says it really simplifies the design and is even more easy to adapt to other type of necessities. Now, as the system they propose is really well designed, it has like a 3 photodetector sensors positioned around the hardware, and using this layout, they are able to detect the position, and obviously as well as any fluorescent measurements that you have to take for those type of cells. And they include as well as other type of filters and other type of systems in order to create it. And there's a mirror system as well in order to bounce this information. Now, the way they test it is by locating in two specific positions, like indicated by the left figure, to A, to B, to C, and they place those sensors, detectors, and it creates like a virtual core in the sample stream that obviously, like we stated, that it removes the necessity to use the fluid, and they really indicated the type of lasers, softwares, and tools that they use, even taking measurements like pressure, velocity, and speed into account in order to compare to the classic or the standard flow cytometers. Now, what they found is, by using in this case the seawater as the testing data, they found, like in the left figure, you can see that's the results that you acquire by using a typical flow cytometer using the sheath liquid. On the right side of the figure, you can see the results using this system they propose, which, as you can see in the axis, it has a much more richer information. They have a more accurate position, and as well as the metrics of detecting each cell is much more improved, and obviously remove the necessity of using the fluid, which is the main proposal of the paper. So the conclusions that we have is this system is able to incorporate accurate and much more richer information, and it can be used in a different type of environmental monitoring, and as well as increasing the range of different tests for immunology, which is the aim of the paper too. The system, as well as is much much simpler system compared to the traditional one, you can then extend the abilities of the system by incorporating a more complex hardware, if it depends on what you need to record. Although the system is immature, because that's what is stated in the paper, it can be used for marine groups quantification, that's why they tested in seaweed water. They included the use of image-based analysis just to make sure it's more robust. And another additional thing that I mentioned is to use a scatter and fluorescent detectors into the system so that it makes appear to be similar to the standard flow cytometers. All of that is just to avoid the system they propose to be less robust. So that's going to make it more robust, even though it doesn't use the fluid of the classic flow cytometers. And that's the conclusion of this review of the paper.